three types of load. One is the resistive load, another one is the inductive load, and another one is the capacitive load. Okay, resistance word is used to for the current. It is used to oppose the flow of current, correct? Inductor is used to oppose the change of flow of current, and capacitor is used to store electrical energy. Basically, capacitor stores electrical energy and inductor stores magnetic energy, right? And it is resistor is used to oppose flow of current, correct? So this is represented by R, it is represented by L, and it is represented by C. Its unit is ohm, its unit is Henry, and Henry is denoted by H, and its unit is farad, and farad is denoted by F, right? Now I am saying if you are having one plain wire and one wire with a resistance, then in that case, in which case current can flow easily, the plain wire or the resistive wire? Tell me. Obviously, the plain wire. Okay, the current can flow easily in the plain wire, right? Now the next case, if we are having the plain wire or the wire with the inductor, now tell me in which case current can flow easily, the plain wire or the wire with the inductor? The plain wire. Similarly, if we are having wire, plain wire and the capacitor wire, in which case current can flow easily, plain wire or the capacitive wire? Plain wire, right? So it means there is some amount of resistance present in the inductor which is opposing the current, right? Similarly, we are having some amount of resistance present in the capacitor which is opposing the current, correct? So that amount of inductance, that amount of resistance is known as inductive reactance, or it is known as capacitive reactance. Like suppose if we are having an inductor, okay, there is some internal resistance present in the inductor, and that internal resistance of the inductor is known as technically inductive reactance. Inductive reactance is denoted by X of L, and its formula is omega L. Got it? So I am writing down the define also. It is the resistance offered by inductor. Okay, and what is its unit? As it is the resistance, so what should be its unit? Its unit is ohm. Clear? Now similarly, if we are having a capacitor wire, there is some amount of resistance present in the capacitor also. That is technically known as capacitive reactance. That is technically known as capacitive reactance, and capacitive reactance is denoted by X of C. X of C is equal to 1 by omega C. It is the formula again. And what is capacitive reactance? Capacitive reactance is the kind of resistance only that is offered by capacitor, right? Now can you tell me what should be the unit of inductive reactance? If it is the resistance, then what should be the unit of inductive reactance? Can you tell me? It's a resistance, so its unit is ohm. Okay. Again, capacitive reactance is also the resistance, so its unit is ohm. Got it? Now the next case, if we are having one resistor, then its unit is then it is denoted by R, and its unit is ohm. If we are having inductor, then its resistance is denoted by XL. XL formula is omega L, and its unit is ohm. If we are having one capacitor, then its resistance is denoted by xc, and xc is equal to 1 by omega c. Again, its unit is ohm. All are the resistance. Okay. But what if we are having the combination of R and L, R and C, and R, L, C, right? We can have the combination of these three terms also now. Then in that case, their resistance is denoted by the term impedance. Remember the impedance term you have studied in the 12th class also. So that is denoted by impedance. If we are using RLC, all the component, then its formula include root of R square plus XL minus XC ka whole square. If we are having R and C, then in that case Z is equal to root of R square plus XC square. If we are having R and L, then in that case we are having root of R square plus XL square. Okay. Again, all these are in the form of impedances, so their unit is ohm. Understood? Clear? Okay. Now the next thing is we should know all the formulas, and we'll get all the formulas by the triangle. Okay. So we are having three kind of triangle. One is the impedance triangle, another one is the voltage triangle, and another one is the power triangle. Okay. So first of all, we'll learn about the impedance triangle. In the impedance triangle, in the base we'll consider as a resistor, okay, and in the perpendicular we'll consider as a inductor resistance. Inductor resistance is XL, or capacitor resistance is XC, and the combination of these two would be impedance, that would be in the hypotenuse. Okay, and the angle would be phi. Clear? Similarly, if we are having, if I multiply the current with the impedance triangle, then what I'll get? Like I into R, right? I into XL, I into XC, and I into Z. That is phase angle phi, right? So I into R is how much? That is the voltage drop across resistor denoted by R, VR. Like suppose we are having resistor, inductor, and capacitor. Okay, we applied a total voltage over there as 200 volt, correct? Now the voltage drop across the resistor can be denoted by VR. Voltage drop across the inductor can be denoted by VL, and voltage drop across capacitor can be denoted by VC. So VR would be equal to I into R, VL would be equal to I into XL, because inductor resistance is now XL. Okay, VC is denoted by I into XC. Clear? So we are having impedance triangle, this one, voltage triangle is VR, VL, or VC, and here is V. This one is known as voltage triangle. So from these triangle we can get every formula. What was the formula? If I'll apply the sine phi, you know what is sine phi, cos phi, tan phi? So sine phi is how much? Tan phi is how much? And cos phi is how much? Can you tell me? Cos phi is how much? That is base over hypotenuse. That is R by Z. Sine phi is how much? P by H. So XL or XC by Z. Okay. And tan phi is how much? XL by R. Got it? Similarly, we can get sine phi, cos phi, and tan phi from this triangle also. Now, if I'll apply the Pythagoras theorem in the impedance triangle, then what would be the value? Like Pythagoras theorem formula is how much? H square is equal to P square plus B square, right? So that would be Z square is equal to R square plus XL minus XC whole square. So if I'll solve it further, then Z would be equal to root of R square plus XL minus XC whole square, right? Similarly, if we are having voltage, then in that case voltage would be VR ka square plus VL minus VC whole square, right? Okay, now these are the voltage triangle and impedance triangle. Draw it.